Welcome to the Edge Microvisor Toolkit demo, aligned with the EMT-S 3.1 release. We highlight a key customer use case ABOS switch feature on a standalone Edge node powered by Intel 13th Gen Core i9 platform. Using this, the demo proceeds to show how to create a bootable USB using the EMT's pre-built image on a developer machine powered by Intel architecture. The journey begins with downloading the Edge Microvisor Toolkit standalone installer from the Open Edge GitHub repository to the development system. The repository cloned successfully. Next, the user executes the make build command to create a standalone installation tar file containing all the required components for preparing a bootable USB device. This will compile packages and all necessary files required for the standalone installation, creates a compressed archive file located in the installation directory. This archive includes bootable USB files, download images, configuration scripts, and any dependencies needed for deployment. This will take some minimal time to complete the process. Once archive file generated, the contents of the tar file are extracted, revealing the download images and USB bootable files. Following this, Kubernetes artifacts are downloaded by executing the download images shell script and provide proxy configurations. Finally, run the preparation script to create the bootable USB drive, as you can see the progress here. The automated installer creates a self-contained USB stick with everything required to deploy the Edge Microvisor Toolkit and K3S. The USB is now ready for EMT-S deployment. In this step, the customer inserts the prepared bootable USB stick into the Edge node and configures the system to boot from USB via the BIOS boot menu. Once the system boots, the automated installer launches and begins provisioning the Edge Microvisor Toolkit. This toolkit includes the base system setup, boot management, utilities, and tooling required for OS deployment. As you can see here, OS provisioning begins and it will take some time to complete. Upon completion, system reboots. On reboot, Cloud Init is triggered to continue the post-boot configuration process. It automatically pulls configuration scripts from local or remote source and begins installing essential runtime components. As part of the Cloud Init configuration, the installer deploys K3S lightweight single binary Kubernetes distribution. It's easy to install with minimal system resources, suitable for both standalone and multi-node clusters. As part of this walkthrough, we demonstrate a key customer-centric feature, the ABOS switch mechanism, which is essential in real-world Edge deployments. This feature helps customers manage OS updates on deployed Edge nodes safely and efficiently in remote locations. We use the built-in OS update tool that comes bundled with a pre-built EMT's image. This tool simplifies the AB update process and allows easy switching between two OS versions. As you can see, using the pre-built OS update tool, the new OS image is applied to the inactive partition slot B while the system continues running from slot A. The update process is then initiated using the OS update tool, which writes the new image to the system. To ensure integrity, the tool performs a checksum verification against the downloaded image. No OS update process completes. After the update, the system reboots into slot B without requiring manual input. If the boot is successful, then the slot B becomes the active OS. If boot fails, the system automatically boots into slot A, restoring the last known good state without user intervention. This approach brings robustness, flexibility, and operational safety to the customer Edge deployments. Thanks for watching the demo.